Hello everyone, welcome back to another video. In this video, we'll be solving another graph question, which is graph connected? Now, a straight prerequisite for this question is get connected components, which was the question which we previously solved, right? This question is just a slight difference from that question. We would be using the entire code base of get connected components. So I require you to go and watch that video if you haven't already, understand that problem, and then only jump on this problem, right? So moving on to the question that we have in hand right now, it is graph connected? Now, if we look at the objective of the question, it says that you are given a graph and you are required to find and print if the graph is connected or not, right? What do we mean by if graph is connected? It says that there is a path from every vertex to every other, right? So a graph is connected when we can have a path from each vertex to other vertex, right? So the input format would be managed for us. We would get a graph, and the output format is that if the graph is connected, we have to return true. That means print true, otherwise false, right? So if we understand the question a bit more better, what it wants to say is, let's suppose we have a graph 1, 2 over here, then 4, and then 5, right? If this is a graph, let's suppose there is an edge over here as well. Now, the question is this graph connected or not? Now, this graph is connected if every vertex has a path till every other vertex. So, does 0 have a vertex till 1? Yes, it does. A path till 1, right? So, the vertices in this graph are 0, 1, 2, 3, 4, and 5, right? Does 0 have a path from 0 to 1? Yes, it does. Does 0 have a path from 0 to 2? Yes, it does, right? Does 0 have a path from 0 to 3? We see over here, yes, it does, right? Does 0 have a path from 0 to 4? If we see, it does, right? Does 0 have a path from 0 to 5? We see 0, 1, 3, and 5, there is a path, right? So from 0, we can travel to each of the other vertices and vice versa, right? If that is possible, this means that this graph is connected. So if we get this graph as an input, then we have to return true, right? Because this graph is connected. This graph is connected, right? So I hope you understood the question. Try to relate this question with the previous question, which was get connected components, right? Try to understand how this problem is just similar to the previous problem that we solved and how we can utilize the previous code base in this problem and solve this question as well, right? Please feel free to try and watch the solution video only if you get stuck somewhere, right? Okay, moving on to the solution of this question. Let's suppose we have a not so connected graph, right? We have a graph which is not connected, right? Let's suppose we have a graph 0, 1, 2, and 3, and 4, and 5, and let's suppose 6 over here, right? Now the indices in this graph are 0, 1, 2, 3, 4, 5, 6, and 7. But if we see, we do have a connection from 0 to 1. We can go from 0 to 1, but we don't have a connection from 0 to 2. This is not possible, right? We don't have a connection from 0 to 2. Okay, so if we don't have a connection from 0 to 2, that means this graph is not connected as we don't have a connection from one vertex to another, right? So what I can say is a graph which has more than one component. A graph which has more than one component is not connected, right? Is not totally connected. Because to have more than one component, you would have two isolated components, and isolation means that you cannot travel from one vertex of one component to another vertex of another component. Right? This is what components meant. They are isolated from each other. So if I have more than one components in a graph, that means I have isolated vertices, right? And if I have isolated vertices, I don't have them connected. That means if my number of components, if I write this more properly over here, what I want to say is if my number of components, right, which we already discussed in the previous question, what components mean. If they are greater than 1, then graph is not connected, right? So if my number of components is greater than 1, again, my graph is not connected. So in this case, I would have to print false. Else, what I would print is true. My graph is connected only when my number of components is equal to 1, right? Okay, so how do we do this question? Now, in the previous question, what we did was we got array list of arrays which contained all the components, right? What I want to say is that if the size of that components array list of array list, if the size of that components array list is greater than 1, right? If the size of comps is greater than 1, then it has more than one components, right? Because size of components just determines the number of components, right? So if we have size of components greater than 1, then number of components is greater than 1, which means graph is not connected, right? So I hope you understood the relation between this question and the previous question. Okay, so let's code this real fast. Similar to previous question, what we would do over here is have a visited, then using that visited, we would go to every unvisited vertices and we would call for DFS, and then we would get the components, right? So instead of writing that code all over again, what I can do is I can take that code from here, right? So from this part onwards, from here till my components part, right? If I copy this and if I go back to my question, which was, is graph connected? I can paste it over here, Control V. Now, over here, instead of printing components, what I have to check is if my component size, right? If I full screen this, if my component size, go a bit up here. If my component size is greater than 1, that means my graph is not connected. That means I would do system.out.println false, right? Else, what I would do, system.out.println, right? Now, if I print this, it is passing our test case. Let's try to submit this for all the test cases, right? Then we would visualize the code, right? So we are getting 10 out of 10, which is a correct answer. So our approach was totally correct, right? If you look at the code again, again, if you haven't checked out get connected components, which was this entire code, I recommend that you do, which was, it is just the previous video from this, right? So please check that out. It would be much more clear to you, right? So what we get is a components array list, right? It contains all the component, right? So this code gives us all the components. This is the DFS that helps us do so. So this is my low level code. This is my high level code, right? This code gets me all the components of the graph. Now, if the number of components are greater than 1, that means my graph is not connected, or else it is connected. That means true, right? That is what I'm doing. I hope you got the question, and I hope you got the point of number of components being greater than 1, determining that graph is not connected, right? I will see you in the next video, which is another application of get connected components. Until then, see you. Bye-bye.